Good evening, dear past presidents, council members, members of the IESL, family members of Professor H Paul, and all the visitors who are cordially invited to the H Paul Memorial Oration today. Please rise for the president's profession. We also welcome our online participants. And today, our president is overseas, therefore, President-elect Engineer Prabodh Jinasena represents him. To start with, I cordially invite the following dignitaries to light the oil lamp. President-elect Engineer Prabodh Jinasena, immediate past president Dr. Kamal Laksiri, all the past presidents. We have a number of past presidents, starting from Engineer Priyal De Silva, Engineer Professor Jodhana, Engineer Gunodhana, Professor Disanayaka. Then our resource person today, Engineer Senior Professor A. Atputaraja, family members of Engineer Professor H. Paul, Engineer Viraj Mutugala, Chairman, Electrical, Electronics and Telecommunication Engineering Sectional Committee. Then a representative from WindForce. I don't know whether they are taking part. And Engineer Neela Besekara, myself. Please remain standing. Our next item, as per the agenda, is garland in the bust of late Engineer Professor H. Paul. I respectfully invite our President-elect, Engineer Prabodh Jinasena, to garland the bust of Professor H. Paul. Thank you very much. Please be seated. Now I respectfully invite the following to the stage. Engineer Prabodh Jinasena, President-elect of the IESL. Our speaker today, Engineer Professor Atputaraja, and our Chairman, Electrical, Electronics and Telecommunication Engineering Sectional Committee, Engineer Viraj Mutugala. Next item is the welcome address by Engineer Prabodha Chinasena, President-elect of the IESL.
Good evening to all of you. Guest speaker today, Professor Abdul Raja, Vice Chancellor of University of Vaunia. Immediate past presidents, council members, Engineer Viraj Mutugala, Chairman of the Electrical, Electronic Telecommunication Sectional Committee, council members, members of the institution, family members of Professor H Paul, Chief Executive Officer and the staff of IESL, invitees, ladies and gentlemen. I wish to welcome all of you to this memorial oration today, Professor H Paul Memorial Lecture. It is my great pleasure to warmly welcome you all to 45th Memorial Lecture of Professor Paul, organized by the Electrical, Electronic and Telecommunication Sectional Committee of IESL. Today is 9th February 2026, and today is the birthday of Professor Paul and 127th birthday of Professor H. Paul. He was born on 9th February 1904. The IESL, as the apex body of professional engineers in Sri Lanka, takes pride in commemorating pioneers whose lifelong contribution shaped the engineering profession and national development of this country. These memorial lectures ensure that the legacy of engineering giants such as Engineer Professor H. Paul continues to inspire not only public but especially younger generations of this country. At a time when Sri Lanka faced significant challenges in the electrical sector, while the rest of the world rapidly advancing, Professor Paul laid the foundation for electrical engineering education in Sri Lanka. And he was regarded as the father of electrical engineering education in Sri Lanka. Professor Paul displayed academic brilliance throughout his career. He obtained BSc degree with first-class honors from University of London at the age of 20 and won the prestigious Kumaraswamy Prize and became the first Sri Lankan to secure first-class honors from University of Cambridge. He returned to Sri Lanka in 1930 to serve the motherland. As a lecturer and later the first professor of electrical engineering and director at Ceylon Technical College, Professor Paul played a decisive role in elevating engineering education, leading to its recognition by University of London. With the establishment of the Faculty of Engineering of University of Ceylon in 1950, he became its first professor of electrical engineering and the founding member of the university. Beyond academia, Professor Paul contributed as a practitioner and advisor to national institutions, including his role in the evolution of the Ceylon Electricity Board. His service was widely recognized when he was elected president of the Institution of Engineers Sri Lanka in 1968. Professor Paul was known as the person with uncompromising standards. He's said to be a very tough guy. Yet he was deeply committed to nurturing his students and colleagues. His life was devoted to uplift engineering education to international standards for the benefits of the nation. In recognition of his exceptional service, the University of Ceylon posthumously conferred upon him the degree on Doctor of Science in 1980. Thank you very much, ladies and gentlemen, for joining this oration today. And I wish to welcome you all again and have a pleasant evening.
Professor H Paul Memorial Oration 2026. Sri Lanka's power sector is entering a defining era. As the nation strives for sustainability, energy security, and economic growth, the way we generate and manage electricity is transforming like never before. Renewable energy integration, smart digital grids, and energy storage are making the power system cleaner, smarter, and more reliable. A new frontier is also emerging, AI-driven power systems that use data and intelligent technologies to forecast demand, improve control, and optimize performance. But technology alone is not enough. Electricity markets and energy policy are vital to guide investment and ensure a sustainable path forward. In this dynamic context, the Institution of Engineers, Sri Lanka presents the H Paul Memorial Oration featuring Professor Apparaja, delivering the lecture, Future-Ready Power Systems in Sri Lanka, Renewable Integration, Digital Grid, Energy Storage. A distinguished expert in power systems, energy economics, and policy, he brings deep national and international insight. Join us as we explore how engineering, innovation, and policy come together to power a sustainable future. Professor H Paul Memorial Oration, Shaping Tomorrow's Power Systems, Today. Professor R.
Let me have the privilege of introducing our speaker today. Professor A. Atputaraja is a distinguished electrical and electronic engineering academic, researcher, and administrator, currently serving as the Vice Chancellor of the University of Vaunia. He holds a PhD from the University of Manchester and a first-class honours BSc Engineering from the University of Peradeniya. Been a chartered engineer of the Institution of Engineers Sri Lanka and a senior member of IEEE, he has made significant contributions to power systems, renewable energy integration, microgrids, and power quality enhancement. Professor Atputaraja has held senior academic leadership roles, including Professor, Senior Professor, Dean of Engineering at the University of Jaffna, and Head of the Department of Electrical and Electronic Engineering I think provincial chapter of the University of the Vatican chapter. Professor Atputaraja has held senior academic leadership roles, including, he has supervised numerous postgraduate research projects, led national level technical committees, and contributed to major energy policy and infrastructure initiatives in Sri Lanka. His work has earned multiple national and international awards, including IEEE and Presidential Research Awards. Has published extensively in high-impact journals and conferences, and actively promoted industry collaboration, capacity building, and sustainable energy development. The podium is for you.
Professor H Paul is known as the father of electrical engineering education in Sri Lanka for his vital role in the history of development of engineering education in the country. Professor H Paul was born on 9th of February 1904, and he was an extraordinarily brilliant student who received his bachelor's degree from University of London with first-class honours through the University College Colombo at the age of 20. In 1928, Professor Paul had become the very first Sri Lankan who joined the University of Cambridge and obtained mechanical sciences tripos with first-class honours. He joined the Ceylon Technical College Colombo as a lecturer, which was the only institution offered courses in engineering in the country at that time. In 1942, University of London recognized the Ceylon Technical College as an institution which prepares students to its prestigious bachelor's engineering degree programs. In 1950, University of Ceylon established its Faculty of Engineering, and Professor Paul was one of the founder members. And also, he was the first professor for electrical engineering until his retirement in 1968. His encouragement and effort led the status of the engineering profession in Sri Lanka to a golden path. The Institution of Engineers Sri Lanka, who had recognized the amazing capability of Professor Paul, elected him as the president in 1968. Professor Paul engaged his life to build an eminent profession of electrical engineering in Sri Lanka, and he sacrificed all the golden opportunities to guide his own people of his motherland for a remarkable profession of electrical engineering.
Very good evening. The President-elect, Engineer Prabodha Janasena, the Chief Executive Officer, Engineer Neil, and the Chairman of the Electrical, Electronic and Telecommunication Engineering Sectional Committee, Engineer Viraj Mudugala, and the Council members, past President, former Vice Chancellors, all senior engineers. I welcome all of you for my talk. My talk will be initially a little bit on overall. Then when I am closer to the end, a little bit on hardcore technical, then finally on again overall in terms of conclusions. So it's in 7 sections. We have wonderful resources, renewable energy in Sri Lanka. We have very good planning, division from Ceylon Electricity Board to Sustainable Energy Authority to PUCSL, even though there are a lot of argument, but they are working very good. Then few pilot projects, not only in very large scale like Mannar, but also in all 4 universities, mostly many universities which are having engineering faculties, they have few pilot projects for checking the economic viability of these projects at the beginning. Then today we have a lot of challenges faced. Then how we are going to solve with the future way forward, and how we can optimize the cost, finally end up with the solutions. So let's see how we are good in renewable energy resources. Hydro, as you all know very well, fully harnessed, but still few low heads hydropower plants, maybe micro level or mini level, are there. Then wind, as we know now, very hot topic this era. We are between Sri Lanka and India, very good, nice wind corridor, as shown in the diagram, these slides. So it's a very good thick wind, very smooth wind, high speed wind available for us to harness the energy from there. Then again, we can see from the Sri Lankan distribution, mostly north and northwest, there are enormous wind potential. even though highland we have potential, but light, not very heavy. The density is low and very hard to rise up with the big turbines. So now when we look from the solar, we can see almost like if you have 1 kilowatt capacity panel, you will get at least 100 units, a minimum 100 units per month as electricity generation from the 1 kilowatt at the panel. So again, enormous potential in Sri Lanka is blessed with enormous renewable energy resources. So let's see how we are planning, even in the past. These are past history I am telling. So planning, mainly the planning is done by SEA, Sri Lanka Sustainable Energy Authority, together with the Ceylon Electricity Board. They are in different sections, but still finally they have to go together for real implementation. So when we look from the recent long-term generation plan, they again re-stressing the 70% electricity generation from renewable energy sources. But there are a lot of argument. Why not 65? Why not 75? Yes, it can go beyond that. We always set some targets and we move towards that. Sometimes we may reach or we may not reach or we may go beyond that. So look from the earlier long-term generation plan. It was planned in 2019. It predicted rapid solar, rapid wind development in the near future. And we have seen now the rapid solar and rapid wind development has been taken place. So mainly the plan was targeting the northwestern coastal area or northern area, mostly in Sri Lanka, targeting to the wind point of view, and solar point of view, again, Hambantota south plus north plus east. And next 20-year period, there were like Mannar, northern area like Puttalam are heavily attractive because of high resources, very smooth resources. So payback is very less, very attractive for investment. And even 2019 itself, they have proposed competitive pricing mechanism. So from 2019 onward, the bidding operation was converting towards competitive pricing mechanism. And still the development is taking place at Punagiri Wind Park or the Renewable Energy Park, where a large number of wind turbines and solar park will be coming very soon, as per the plan in 2019. So let's see some pilot project. I remember in 2014, when the ADB put money on Hambantota Solar Park, they were giving some more grants to establish in all 4 universities, Moratuwa, Peradeniya, Ruguna, as well as Jaffna, engineering faculties, just to demonstrate to the public, because we don't want public to hesitate on renewable energy power plants. This was a story in 2014 and 15. So accordingly, all 4 university rooftop solar plants pilot projects was established for demonstrating to the school children and surrounding people, even from the Jaffna side, where I was the dean at Faculty of Engineering, Kilinochchi. So I'm talking because of I was there, but all 4 universities did the same thing. So we opened the power plant, the pilot project, and opened to school education, school children, accountants. More than 100 accountants came from northern province and see the place, and many government organizations, school principals, government organization, industry leaders, HR people, and the developing engineers, everybody came and visited that. So they were able to see if you put this much of money, when they can get the money. So even without knowing the technology, they understand how this is operating and economically viable. So we can see it's about 60 kilowatts panel, 55 string and 5 micro inverter base. So altogether it was producing about 250 kilowatt per day. You can see the graph for every day, and it's almost like 1 kilowatt panel producing about 125 kilowatt hour. That means 125 units per day, per month. So this give high energy production is possible, and the feasible payback is so low. So even it has proven that in the pilot study, that 125 units per month can be produced. So you can now convert with the cost and everything. The tariff varies with the time. People can understand the payback out of that. Then second part was, again, we thought not only rooftop. Now you can see northern, especially in Jaffna district, no more rooftop because it's all full. People has captured because it was high benefit. That's the main reason. Maybe now the thing we have to make it to, initially the direction was promoting renewable energy. Now renewable energy become economical viable project. So now we have to move towards economical point of view, how the renewable energy can be play a major role to help the Sri Lankan economic boost. So then we found that over the pond, there are enough space. So floating solar is another important technique. With the help of Norway government, this was established. And we studied how the floating solar produce energy. It was almost like 5,000 kilowatt hour per month, every month, 46 kilowatt rated floating solar. Whenever we check, the cost was at that time 2020, it was 9.4 million, 9.5 million cost. These rights will be given to everybody. So you can read through the individual items later on in detail. So when we check through the floating solar, about 66,000 units was generated in the year of 2021, 1 year, almost like 181 kilowatt hour per day. Or in other words, 1 kilowatt panel produced 118 kilowatt hour, 118 unit. But just before I told you, rooftop solar produced 125 units per day, 1 kilowatt. But floating solar is supposed to produce more than that. The reason for less here is the orientation. Floating solar was oriented in a different shape because it was a Norway design. Now we are converting into the Sri Lankan design. Sri Lankan design will definitely produce about 150 kilowatt unit per day if we have the same capacity. Because this was not in the south face direction. This was in the east-west direction face. Because of Norway design, it was designed for that purpose. Because Norway is, in the top of the earth and we are in the central part. So there are two different designs. But anyway, we demonstrate the technique and it is feasible. It is become economically viable even with the lower production. Then the hybrid power plant, which was again made in Eluvadiv North by the Ceylon Electricity Board as one of the research outcome from University of Peradeniya with engineer Mr. V. Radneshwaran. Eluvadiv is the small island. You can see in the red color marked. A very small island, 3 kilometer, 650 meter width, about 125 families. There are 6 wind turbines, each was 3.5 kilowatt and 46 kilowatt rated this solar panel, 30 kilowatt diesel, small diesel plus large diesel, another diesel was there, large diesel. Then again, 110 kilowatt hour capacity battery bank. This was the plant at Eluvadiv. It's almost like a small island which has wind, solar, diesel, battery. It's a very good, very strong pilot project for our studies. All the engineers, I believe, they have to grow up with learning these technical operations. If we check the circuit diagram, very fantastic. It's a lovable pilot project implemented by the Ceylon Electricity Board for the educational purpose. I'm sure we all have to tie up together to keep on running without losing that now as about 2016 till 2026, 10 years is gone. So batteries are going down, so we have to pack it up. But this is one of the excellent study where the research or development or even undergraduate student can really feel as a islanded microgrid operation. And also, of course, University of Moratuwa has another microgrid operation. So this kind of inside the universities or very close to the universities, developing this kind of pilot projects bring us enormous knowledge gaining with the real practical experience. So you can see even that island has how much power generated from energy generated from wind, solar, and 2 diesel power plants. One is small and one is larger. So out of total 140 megawatt hour for the year. The wind and solar together 29 plus 55 megawatt hours. So it's almost come to 59.7% the renewable energy contribution, where this has been supported with the battery, 110 kilowatt hour rated battery. So these are good examples for us to study and understand in a pilot. It's in the real on the ground, serving to the people. So many people, 125 families, about around 600 people are gaining the benefit out of it. Not only that, when I went to the Eluvadivu, initially they were not even finding crabs and everything, but now they are exporting crabs because they have ice factory and everything with them. So the development taken place, GDP is increasing from that island. So these are some further example of how the energy share in the Eluvadivu plant. Let's see the next part. Again, the recent development, August 2025, after becoming a Vice Chancellor at University of Vavuniya, I thought, why don't we catch up some more money from the sun for the university development? So we got a ADB grant, 30 million rupees. So that was about, out of 30 million, we put about 24.7 million in August 2025. It was started in around November 2024 with the first letter of request. Then it was implemented in August 2025. So that was again another wonderful place with the Net Plus Plus. Brought a lot of money for us. Up to now, from August till December, we got 3.4 million. That was the contract with 27.06 rupees. Now it has further reduced, but that time it was getting down from 39 to down. We were trapped the contract with 27.06. It was a good study for us. With that one, we found simple payback around 35 months, 3 months. So that means the reduction of, I know some of you may not be very happy, but reduction of the solar tariff, because now we have, initially we were promoting renewable energy. Now the renewable energy become economically viable and it become economically profitable. So now the time has come to put the weight on the renewable energy shoulder to reduce the electricity cost. So now the reduced electricity cost has come down to about 14.46, 14 rupees 46 cents. So from, it was drastically reducing. I know people are worried, electricity bill is high, many things are going up. It is true, earlier renewable energy was on the promotion side in 2014 onward. Slowly it became economically viable when the large number of manufacturers or the developers come to the country, the per unit cost become reduced, the life become little easy, not very easy, but little easy. Then the price have been now under the competitive bidding process. So it has come to about, I think, middle of 2025 or latter part of 2025 onwards to this price. Then again, I'm just telling some confidence building on renewable energy, where we are going to move with that one in the future. So now let's see whether 10 megawatt to 100 megawatt, what are the projects have been already developed, implemented, operated, and we have gone along with those projects. So you can see here from 2013-14 onwards, the solar and wind development was taken place. Of course, last 3 years it was a little bit less, but solar has boomed up a lot. So again, in the graph, you can see the yellow color graph is going up in the hill because of the solar was very attractive. Again, this other renewable energy has contributed about 22% from the total energy. So the renewable energy share is being increased slowly. And if we take up the Mannar wind power plant, which is about 100 megawatt, $157 million capital investment, which has estimated 6 US cents per unit at that time. So it was just before the corona. It was very well successfully implemented. One of the very successful projects implemented by Ceylon Electricity Board, even though some social issues are raised up. Social issues are the flood. I think you all know exactly, engineers, the flood won't come unless we have not developed the infrastructure properly. When we generate 370 million units per year, each unit may be say 30 rupees or 80, 20 rupees, 6 cents mean. So we can simply develop the infrastructure. So if we properly develop the infrastructure, wherever the culvert need to be placed, we put culvert. So it restore the system, there won't be any problem. So whenever we develop, we have to develop properly. But I know there are some restrictions to develop the infrastructure too. So that need to be handled by the district secretariat or the people in that area who are the well-educated people. So then when we look from the overall Sri Lankan renewable energy point of view, contribution, 55% renewable energy contributed in 2024. This was some slides taken from Dr. Tilak Chemalapati at the NIS 2026, Northern Investment Summit 2026 presentation. Of course, 1990 we were 100% on renewable energy. 2016 we were fully electrified, almost 98% or beyond that. So now the point is we are contributing about 55% from renewable energy, including hydros. If you look from the recently developed or up to now 2024 end, what are the plants developed? 217 power plants, mini hydro are developed with 432 megawatts. 19 wind power plants are developed with 163 megawatts. And plus, those are private, then plus one from CEB, 103 megawatt at Mannar. Then ground-mounted solar, 93 plants, 170 megawatts. And biomass waste, 15 plants, 63 megawatts. And rooftop, 1 lakh unit almost with 1.5 gigawatt. So big challenging is rooftop. We will see what are the challenges is created. So at the moment, these all other renewable energy contributing 22% to the grid energy point of view. So what are the challenges we are now facing? This is where I have to slow down from now onwards, because up to now, majority of you knows what is the data. I collected the data and presented, but there are more data available. I was able to collect only this much, unfortunately, but I know in Sri Lanka, more than 4 universities are working on research. So many research are coming out. I couldn't trace everybody's outcome because as a vice chancellor, I need to spend about 18 hours per day for the university. But still, I love to serve this one because I am one of the person from E91 who got Professor H Paul Award for electrical machines and power system from University of Virginia at the convocation. So I'm very loud to give the memorial oration for Prof. It's wonderful opportunity for me. So I don't want to say no to them. I wanted to capture it. So I was able to capture this much of slides for you. This is open to everybody, researchers, academics, presentation, take PPT as it is and use it as you wish. Open source, free education. So let's see the challenges faced by the with the increasing penetration of renewable energy. Actually, we were promoting renewable energy. It has come up to the point now. It has captured our neck now. Now we are in the point of we had to put some competitive bidding. That was okay because promoting and putting on competitive bidding, it will grow up if you properly made it. Then the problem is still we have to absorb. You can imagine 1.5 gigawatts of rooftop will give us tremendous trouble in the daytime. Peak 12 o'clock, they have to shut down many power plants, including renewable energy, controllable plants. So many plants need to be shut down, curtailment. So what to do? Let's see start from the basic challenges. First basic challenge is power quality. Power quality is always a problem because intermittent nature of the solar. But tremendous development has been made. When I did my PhD in 1998, we did so many solutions at United Kingdom, National Grid Company. Then postdoctoral research fellow at University of Queensland, Power Grid, Australian company. We did a lot of work on how to prevent the power system blackout. Research and development and dissemination and finally implementation. Then again, Unit 10, Tinaka National, like CB. Unit 10 is a Tinaka National own full-time research university. There we work on electric vehicle integration and battery energy storage and how to prevent this load shedding, load shifting, and power quality improvement, stability improvement, all of those. So these are summary of those all, coming as a summary of, Sambara like that. So basic challenges. One is intermittent nature bring power quality. Now it is old because power quality problem is being mostly solved by device itself. You can imagine wind turbine is rotating. When wind increase, it's allow speed up, flywheel action, store the energy, but electrical energy is constant. When the wind is slow, it slow down the speed. That kind of flywheel action, mechanical engineers can understand very well. Flywheel action created by the power electronics inverter. Power electronics inverter is a magic. Within millisecond, it will respond, or microseconds, few microseconds. So it will respond. Then it will control the speed of the plant. That means device itself, that means wind turbine itself, so that fast fluctuation is attenuated. So likewise, so many development taking place. Not only that, there are many others. So second part is seasonal. Sometimes wind power plant give high power in June, July, and low power in March, April. So we need to operate with hybrid. Then again, when we operate with hybrid, the power purchase agreement with other power plant lock us. So we have to carefully develop the power purchase agreement, at least for the future. But in the past also, they develop very well. There are many power plant owned by CEB which have been hybrid with the renewable energy power plant. Then again, some disturbance. 9th of February 2025 is a good day. I mean, it's a bad day for Sri Lanka, good day for the power system engineers. One challenge came and we have to wake up and see where it is gone. So that trip of that line at Panandura brought whole country blackout. So how we can solve those kind of blackout problem which are unpredicted. We don't know. Monkey will jump in or lightning thunder will come in. So anything can happen to any power system, very vulnerable. So how we can automatically, even without human interference, that should act immediately. So the power system engineers had to proactively see through this all and develop. I think our CB system was fantastic. They were doing very well, but operational and maintenance had to be keep up to safeguard throughout the night, throughout the period. Then the bigger challenge now we are facing is curtailment. Whenever we do curtailment, this was planned. Even the 2025 long-term generation plan has confirmed we are going to make some curtailment. This is unavoidable because of 1.5 gigawatt rooftop solar came in. As all electrical engineers knows, I think Dr. Dilak pretty also re-stressed in the Northern Investment Forum. We can't generate more or less electricity than the demand. So whatever the demand is there, we have to follow it up. There's no other choice. So if we generate more, we have to dump it to somewhere like battery or any other energy storage. There are energy storage, not only battery, there are many varieties. Pump storage, very well research was done by Dr. Kamal Laksar in the past. So many things has to come out. We have to take all the high caliber professional work out of the screen from now onward, because we are in the bottleneck. At the neck, the things are come up to the point now. But very good development. But this always happens. Whenever we are pressurized, we have to open up more and more professional research and development, and that outcome has to be implemented. So curtailment, this is in the long-term generation plan itself. So that is one of the challenge. Let's see how we can solve these challenges. Now I am taking you a little bit hardcore on technical component. First part is power quality problem. Still, this is old, around 1998. But don't worry, power system will never change drastically. It always change slowly. These have been implemented. This is the work I did during my PhD to the Alstom and Siemens, two companies, two industries funded my PhD at UMIST, University of Manchester Institute of Science and Technology. So that time, the power quality was a serious problem. Now, Even now we have solved that problem, but more than the problem now we have is curtailment. But I will first solve the power quality. So power is changing always up and down. Wind is intermittent, solar is intermittent. Whenever we wanted to go to renewable energy, now the point, just take a few steps back. In 2002, when I came after the PhD, everybody was telling that fossil fuel going to increase the cost. So therefore, we had to go to the renewable energy. But still, renewable energy is high cost. So that's a good time. We didn't jump into the renewable energy rapidly, but we were slowly getting into the renewable energy, see the technology development and operations. Now we have seen fossil fuel has gone up in the cost. Now renewable energy cost is coming down. So this is the correct time. We have to move into the renewable energy time. Then again, we are moving into the renewable energy, which will create a lot of problems like this: power quality, stability, and some other reliability, even curtailment, all will come into, because renewable energy power will be available when the sun is available, when wind is available. So we have to store it. Then storage will come into the picture now. So that is the era now we are passing through. So this technology, the fluctuating power on one side, this side power is fluctuating, this side is smooth. This side is under double fed induction generator, wind turbine. That side is under fixed speed. So two different technologies. These are old technology again. Fixed speed is 1980 technology. Double fed is about 1998 technology. Again, 2000, 2010, full range inverter based wind turbine came. That means class D wind turbine. Some of you know. So the development of technology remove all rapid fluctuation and bring the reasonably smooth fluctuation within that average power. Within a short period, it averages, like flywheel action. So some level of power quality problem was solved by the device itself. Device means generator, wind generator itself, or solar inverter itself. Even the solar inverter has massive facility. We are not utilizing still so far. Then again, this plant, this place, you can see if you wanted to improve the power quality, basically the double fed wind generator, you know the torque speed curves. Some young people can still remember torque speed curve. That will be shifting this way and that way. Early days, we don't shift it because the induction generator, resistance, and inductance are same, fixed. Nowadays, we open the induction generator rotor winding and inject the voltage. So we are varying the resistor and inductor so that the torque slip curve will shift up and down. So whenever we shift, we can avoid any kind of power quality problem. That is where when the torque slip curve shift, we are allowing the machine to speed up. Or when the torque slip curve is shift other way around, we allow the machine to slow down. So by doing that, we are storing the fluctuating power as a flywheel action into the rotor. Tons of mass is rotating in the wind turbine. There, the fluctuating power is stored. There are so many. Otherwise, if you have a different wind turbine, you can have STATCOM BS. Now we have Biagam as STATCOM is already implemented. So STATCOM is not new to us now. It's a power electronic device with a battery energy storage or capacitor storage. So we can operate them. There are enormous control opportunity where the grid current can be kept constant by load current vary like this, injector current vary, and grid current remain constant. That means grid current remain constant means here the power is remain constant. All of the fluctuating power will be coming from between this and that. No deal to the grid. Grid is fixed. So that is another way. So these are viable now. So this is what called STATCOM, the full capacity. We have to utilize the full capacity, full options available in that device to make use of our purpose. For that, we need capacity building. Of course, in this country, there are many PhD holders from Peradeniya, Moratu, and Jaffna. Some senior people have the PhD in this area. So they can be harnessed. Maybe we will be very loud to give our knowledge to others because we all got free education to get this knowledge, full scholarship, everything. Solar inverters. Solar inverters, again, as you know, this solar inverter is simply like a model like this. It's nothing cutting edge technology. It's simple. So if I vary the delta, it's inject active power or absorb active power. If I vary the magnitude E, it's inject reactive power or absorb. So active or reactive power injection can be controlled simply by controlling the E magnitude and the angle. That's same as 4-quadrant control. We all have learned from second year of electrical engineering education. So this is the simple technique used in the inverter. So what we have to do is how the inverter functioning, how this pulse width modulation working, how that create this shifting the E or shifting the angle, changing the magnitude of the internal voltage or shifting the angle of the internal voltage. This part for young researchers, there are many young researchers sitting here. They can see these are not cutting edge technology. These are very fundamental electrical electronic engineering. When I was establishing a DVR at UMIST, I will show you some diagram later. The Alstom person told that it has to work 100%, at least 98%. So my DVR is working only 80 fault is rectified, 20% fault is not rectified. He said wrong. He will not buy my DVR. So my research funding, I am hang on the roof. So I was thinking the transformer interest current is a problem maker for me that balance 20%. Because when you switch on the transformer, at the point of the sinusoidal you are switching on, it will create high current or low current. So sometimes high current. That is where the 20% mistake was happening. So I tried to put the limiter for that. If it is switching within that period of the sinusoidal, quarter, 25% of the sinusoidal, then I put the limiter. Then my problem solved, 98% success. So my product was sold out to Alstom. So these are simple. I learned that interest current in the second year. I am sure most of you learned from second year. So these are very simple technology, which has helped me at the time of the PhD, where my product is almost closer to the selling position. So you can see the solar. Solar, this curve everybody knows, most of the electrical engineers. So if I operate here, maximum power will be taken. If I operate slightly high, power will be reduced. Here, again, if I increase the voltage slightly, power will be reduced further. So instead of switching off the solar power plant, you can curtail the power by shifting the operational point. So that's again available. Same inverter control can be utilized, but only thing we have to develop the policy and the guideline for that. Now you can see earlier hybrid converter was not allowed. Now hybrid converter is allowed. Similar way, maybe another 5 years, this operation will be allowed, because rather curtail by switching off the power plant, you can curtail by blocking the power coming out from solar cell. Just increasing the voltage at the DC, at the DC voltage, this voltage, if you increase, power come from solar will be blocked to the solar panel, not to taken in. So that way we can curtail. So we have some, quickly we can restore without any delay, even few milliseconds. So there are so many things we can open up, because now the current trend is so many renewable energy we have already absorbed, but we need to optimize the absorption without curtailment or minimize the curtailment, because curtailment also cost. It always cost. So let's see, that is about the quality and few other modernized control, which all are digitalized control. I didn't put the word digitalized because sometimes you will feel far end up something very high modern technology. No. These are all basic fundamental electrical electronic engineering to build up to some level. Then if you wanted to learn more, you can join one of the university, do the MPhil PhD, you will be the master for that. Then again, power stability. Basically, we all learn that when we operate in this region, we are stable. If you go beyond this region, we are unstable. So whenever the blackout happen, or some kind of, not blackout, small voltage dip happen, couple of seconds, then the generator will speed up. Then if I shift the torque slip curve this side, if I shift the torque slip curve, I will never go beyond this point, because this point also shifting. So I'll be always operating in this region. Can you understand? We keep the torque slip curve slightly shifting, so we are still on the safe region. because now the shifting is possible. How it is possible? There are many ways. You can keep the same starting point and stretch the curve. That means only changing resistor of the rotor. It will stretch the curve. Second thing is, you can change completely the frequency of the supply. Imagine I have grid. I have AC, DC, DC, AC inverter. This side is wind turbine or anything. If I wanted to, I can keep the wind turbine, grid frequency as 50, no problem. DC is a couple. DC means only power is couple, no frequency, no phase angle. So only power is couple. So this side, any frequency I can operate. So if I increase the frequency, the curve will move like this. Curve will move like this, shift like that. Synchronous speed will move. Speed is increasing, frequency is increasing. So curve will move. So this operating point will move. Always I am on the safe side of the operating point. I will never reach to the unstable operation. So stability improvement can be made now. These are again already implemented. Sometimes 5 megawatt wind turbines having this technology already implemented. So it's not, I am telling everything implemented. This was in the research 1998. Now it's all in the very high level, economically viable commercial market. So that is other one. Other one is, of course, this is again one of the old technology. When somebody put so many fixed speed turbines, then during the blackout or during the power failure here, small fault, they dump the power to the breaker resistor. That is an old technology. That's again 1990 or 2000 range technology. But now they don't dump the power into the breaker resistor because we are wasting the energy. So we allow we dump the power, the electric power as a mechanical power into the turbine or battery, chemical, or pump storage. So many possibilities are there under energy storage category. So this is again, because when I present like this, maybe in 2002, we don't easily grab the message. Now we are in the position, we have to grab the message, we have to take the lead forward. I'm sure the academics, researchers, industry, real engineer, senior engineers, massive experience have to be merged together and get the outcome for the country development, national development. These are some of the studies. Even IEEE 12 bus system is standard. So you make some break here, grid is being disconnected fully off, then this side is working. So then it will collapse because frequency go down, collapse, total power system blackouts. So you have load shedding. CEB has load shedding technique, under frequency load shedding technique, under voltage load shedding technique. But the technique itself is a little bit old. We are working with the range of few seconds response. But the technique has come with the range of 20 millisecond response, fraction of second response. So we have to upgrade the load shedding technique so that the action will be made immediately. Still the breaker will take some time. That's a different part. But action will be taken. I mean, the brain will take the action instantly. So that the breaker mechanical opening will take some time unless we have other breaker system. So now you can see there are load shedding happen. Soon after they realize the frequency is going down, then frequency is coming back. So frequency will automatically restore. These are automatic. This cannot be done manually. These are fully automated. That means the power system is a very strong system which is interconnected. Only one frequency is available. Frequency may slowly vary between north and south. But still, when you have the rigid system, very rarely both will run same frequency. When I say frequency vary mean, it's okay. It's maybe about 0.00 fraction. But usually frequency remains same. So this is again load restoration. We don't do load restoration automatically. When the system control give the command, then load restoration can be done automatically too. But these all proactively studied, carefully studied, and stores the operations. Then according to the planned activity, operation will be implemented. Let's see solution to the energy curtailment. Very serious problem, but I don't want to put my thoughts too much into this because I know industrial engineers are here, Ceylon electricity board engineers are here, senior engineers are here, and investors, maybe they are, again, engineers. So I take the CB long-term plan where 30 engineers work together with a very visionary purpose. So their point of view is perfectly, I also match with them almost. The large-scale battery energy storage become unavoidable now. If you want to capture the curtailment. If you don't want to capture the curtailment, then we can still leave that. But if you don't want to, but curtailment is again 1 million unit per year, something like that going to be curtailed. So 1 million unit means 20 billion rupees. 1 billion unit means 20 billion rupees. So we don't want to go into the curtailment. Therefore, we need to go with the fast acting energy storage technology, which mostly fall under battery at the moment. Then again, our long outstanding high-level research was done by the leader of Dr. Laksari in the past. But I think we have to restore the outcome, and if any problem, we have to study again with the recent situation after this whole tsunami, the cyclone. Then we have to see whether how we can do. Pump storage is no harm to any places. It's again environmentally well-friendly operations. Battery, we have to worry about when we are going to discard it, how we are going to discard it. That's always there. Even we were talking about discarding the solar plant long time back. Nowadays, we forget that solar plants are everybody's head. On top of the head, solar plants are there. So battery also the same problem, but I hope something will come up very soon. So pump storage is one of the fantastic, but we have to, as engineers, we have to see whether how we can take it, what is the mistake, what is the root cause of the problem, can't we take it forward? That's one of the wonderful technology if we can take it further up. Very large scale power will be dumped without any problem. Then again, India-Sri Lanka connection, that is depend on the political discussions. So as per the long-term generation, we are going to cut about over 1 million unit, 1 billion unit for the curtailment. If we go like this, so if we bring the other technology to safeguard the curtailment, then the benefit will be, now we have to see whether cost versus benefit. Again, power system economics has to come into the point, which one is benefited. But if we think in advance, well in advance, before this high penetration of rooftop solar, we might have escaped, we might have realized this curtailment going to come very soon, because rooftop solar is only available in the daytime. So daytime loads has to be increased. So daytime industries has to be increased through putting up so many BOI. Or daytime electric railway has to become to the front. Or many other daytime operation has to be increased with the loads. But we haven't done that. Now we are a little bit delayed. So in the delay, the catch-up is the battery energy storage coming into the place. Then fast frequency devices. Okay, fast frequency response devices. We only need in the order of seconds, but I just give you some examples. We don't need to worry about seconds. Power electronics are in milliseconds. Some of the experimental with the 10 kilowatt, which was implemented and proven, this is the device I sold to Alstom and Siemens after my PhD. From University of Manchester, Institute of Science and Technology, I got £1 for my research. That means more than the research grant and my salary and everything. Simulation versus experimental. Mostly they are matching. They are not far different. If we properly model all the component in the hardware into the simulation, they will be matching. So you can see with the grid side, constant current. This is on the load side, fluctuating, that is injected by the STATCOM. But grid side, constant current. So grid side is fixed. This is in single phase. Voltage, blue color, going up and down. Red color is load current going up and down. Green color is injector current 0, no STATCOM. So when the load fluctuates, voltage fluctuates. This is the flicker. Then this is when the load fluctuates, black color graph fluctuates. The pink color graph also fluctuates. STATCOM inject. So the voltage remains constant. This is proven in the thing. So to do this, one cycle is 20 milliseconds. You have to inject within fraction of a cycle. So within 2 milliseconds, you have to inject. Otherwise, it won't achieve. So the response times for power electronic device are few milliseconds. This is for 10 kilowatt. Imagine 10 kilowatt, we can do this. So 225 megawatt STATCOM implemented as the first STATCOM in United Kingdom in 2000. Whenever you upgrade the rating, your device resistor inductor component become much small. So response become further fast. RL response become faster because R and L are very slow, very small. So you can achieve within a couple of milliseconds. That's the meaning I'm telling. Whenever we think we need at least a frequency response in seconds, we can simply reach, because the power electronic devices are geared to response within few milliseconds. Again, when I say this is 3 years of PhD work, and 3 years of PhD work mean day and night work every day, right? Without weekends. So that is the level of work you need to grab from here. I know this is just a very surface level information, but we can again give you in detail. Whenever somebody needs, please join one of the university as a postgraduate. Definitely you'll experience, because now the time has come to us to realize and understand what we are doing. Okay, so this again still slides from Dr. Tilak. From 1996 till 2025, slowly the renewable energy was promoted in 1996 with high-end power purchase agreements. Slowly it's come to slightly tied up, but during the 2022, again some feeding tariff was enhanced because of the corona impact and the country economic down. Then again 2025, now again competitive bidding come. So little pressurized to the investors to, because whenever I get more money, that money is coming from the public electricity tariff. So we have to make sure we also earn some money. That means investors. At the same time, the public, we also pay a little bit reasonable cost. So that is where the tariff come into the picture, where purchasing price is coming down. And again, electricity tariff, I hope your electricity bill will be 10 to decrease or 10 to decrease the increase, right? Okay. So now the point, we have come to the point, we are pressurizing the investors because we are going to pay less money, 14 rupees, 15 rupees. So now we have to make their life easy. This is one of the outcome from the Northern Investment Summit, because all the renewable energy plants are in the northern province. So when we discussed, they said, we are spending years and years to get the land and implement the project. So they are the government agent, district secretariat, divisional secretariat, everybody has to work and simplify, easy the investors' life. That means when they bring and put the money, they have to get the business out very soon. So I believe the one-stop shop investors forum, that means a portal where people can come and do everything in one place, will be benefited much more. That means investors friendly environment has to be created. Then investors will come very happily, even though the profit is less. So that is, we have to push forward as an outcome of this work as well. Then holistic approach on, that means whenever we have to develop the policies, not only for electricity, but also for the industries. We have to form more and more industries in the places where more and more renewable energy is there. Because mostly, especially solar, which is proven as a very profitable projects, we had to parallelly, we had to put the loading capacity also together with that. That means BOI industries has to be established regionally. So it will bring more benefit to the country. Then again, electrify the railway electrification, which was all good. I remember about 20 years ago, we were discussing drastically on this direction. And of course, EVs maybe 10 years ago. Pump storage, more than 15 years ago. These all has to be clear the dust and take it to the front again. I think it is already in the long-term generation plan of the CEB. That is perfectly indicated. But only thing is, we all have to work as a united way to implement. We have to see constructive comments, and this has to be taken to the implementation. Then again, yes, pump storage has to be taken. Grid connection, even of course, it is a little bit difficult for us, but still, professional has to take the advantage of checking the goods and bads of the grid connection, not only nationally, but also internationally. Internationally means next to India. So how this is good or bad? Some conference can be organized to discuss. Then it will come to the good item later on. Then again, offshore wind power plant, again, another biggest, huge resources available to us. That also we had to tackle. At the moment, of course, low-hanging fruits, the onshore wind power plants have been continued, but offshore plant studies have been already started. And hydrogen energy storage, which is again booming new technology, that also can be penetrated into that one. At the same time, we have to make the people awareness on how to dispose the waste on electronics and batteries, those kind of things, environmentally friendly things. So in conclusion, Sri Lankan power system going to be more challenging with integrating more and more renewable energy-based power plants. No doubt, it is going to be the case in the future. So how to tackle the modern digitally monitored technologies? Whenever we say STATCOM, it will monitor many places and grab the information, and accordingly it will operate. So digitally monitored, and it is also very flexible and fast acting. Flexible plus fast acting. On the spot, it will inject the required amount of active power or reactive power, which is required by the power system. That kind of high speed control is available in STATCOM. We have to make sure everybody understand in depth of STATCOM operations. Then again, energy market is not going to be same as what we did. All good days, when we have a couple of power plants, very easy to schedule. Over the phone, say this, that, finish. But nowadays, so many power plants, we have to go by some simulation package. Now going to be very complicated energy market, where the customer will be able to get the power from some specified supplier. That's going to come another 5 or 10 years. So our energy market become very complication. I won't say complication. If we try to do manually, it's complication. But there are so many packages, so many automated system, which will do for us. All we develop, but that work for us. So with that one, I completed my speech, and thank you so much for learning till 6:45. We started at 5:45. Thank you so much, and wish you all the best. I hope this talk has bring some information to you. I open to the chairman to open for PPT or PDF, whatever you want, and disseminate the knowledge using the slides to anybody you wish. Thank you so much. Thank you.
Thank you very much, Professor Puttaraja, for your highly informative speech. We have a big challenge for CB engineers, railway engineers, our investors there. Probably you may have to find ways to find new techniques. And now it is the time to pay the gratitude to our speaker today. I cordially, respectfully invite our President-elect, Prabodh Jinasena, to hand over the memento to our resource person. Thank you very much. Our last item today is the vote of thanks. given by Engineer Viraj Muthugala, the Chairperson, Electrical, Electronics and Telecommunication Engineering Section Committee.
Thank you. Good evening, ladies and gentlemen. Memorial Orator, Vice Chancellor of University of Vavuniya, Professor Puthraja, President-elect of ISL, Engineer Prabodh Jinsena, Past President, Engineer Dr. Kamal Laksiri, Vice Presidents, Council Members, CEO of ISL, Engineer Neil Abheshekara, dear relatives of Professor Paul, distinguished guests, members of the sectional committee, all the participants, and ladies and gentlemen. It is my greatest privilege as the chairman of Electrical, Electronics and Telecommunication Engineering Sectional Committee to deliver the vote of thanks at this memorable Engineer H Paul Memorial Oration for 2026. First and foremost, I would like to express our sincere gratitude to the guest speaker, Professor Puthraja, for accepting our invitation and delivering highly insightful memorial oration under the topic Future Ready Power Systems in Sri Lanka. I believe that the audience had gathered a wealth of knowledge from your presentation, sir. By selecting such a timely and relevant topic, you have addressed the pressing needs of the power sector today, and also at the same time, you have paid the rightful tribute for the Professor Paul for his vision and his legacy. And at the same time, your valuable insights related to renewable energy, digital grids, and energy storage has enriched us all. Thank you, Professor. And I would like to thank the family members of Professor Paul. We are deeply grateful to have you here with us today. Your presence and participation has added a special meaning to this occasion. Thank you for participation. And my heartfelt thanks goes to the president of ISL, Engineer Kosala Kamuradiniya. Even though he is not physically present here, I would like to remind his blessings, his guidance, and also the encouragement provided by him in order to make this event a success. And I sincerely thank President-elect Engineer Prabodh Jinsena for gracing this event and providing the rightful leadership for the success of this oration. Thank you, sir. And I also extend appreciation to all the council members and all the past presidents of ISL for their guidance and continued support. You are the pillars of success of this organization. Thank you. And I would like to thank the sponsor of the event, Windforce PLC. Thank you for your generous support. Without your support, this event won't be this much successful. And I would like to express a special appreciation to the advisors of the sectional committee, Professor Andra Vijaypala, Dr. Narendra De Silva, Engineer Chamille Durumini, for your valuable guidance and support. And also, I would like to thank Vice Chairman of the sectional committee, Engineer Navodana Kamkanange, and Engineer Janaka, and Engineer Sandima, and Engineer Sapumal, and all other executive committee members for their hard work and dedication behind the scenes. I gratefully acknowledge the Chief Executive Officer of ISL, Engineer Neil Abheshekara, and his dedicated team for excellent coordination and continued support in making this event a success. Thank you. And finally, I would like to thank all the participants, both physically and online, for your presence and engagement, which had made a true meaning to this event. Thank you. So as we conclude, let us remember Professor Paul not only as a distinguished leader, electrical engineer, academic, but as a visionary pioneer who had laid the foundation for electrical engineering education in this country. He is remembered as the father of electrical engineering education for his pioneering role establishing structured electrical engineering education, nurturing young engineers, and shaping the academic and professional standards of the discipline in this country. His legacy will continue to develop generation of engineers to serve this nation with dedication, knowledge, and integrity. With that, I would like to conclude my speech. Thank you all. I wish you a pleasant evening.